Hello, I'm Nobby. Welcome to my workshop. The final job to do on the flywheel is to drill and tap a hole in the rim of the boss here to take a grub screw so it can be locked onto the shaft. The plans say set the flywheel at an angle of 20 degrees and check that you've got sufficient clearance here for the drill and tap. What I'm going to do first is machine a little flat on here so that I can get the drill nice and square to the surface at that angle. I've got a 3mm end mill here, 4-flute end mill, I think quite a nice quality one, so I'm hoping that's going to do a good job. Then obviously that will be followed up by putting a spot drill into the centre here, drilling it 2.6mm and then threading it for a 5BA grub screw. This is all set up in my angle vise. Bought this quite some years ago. It's not a thing that I use a great deal, to be honest. I've drilled quite a number of holes in flywheels in the past to take grub screws, generally at this sort of angle actually. But it's a sort of a useful thing to have. Searching around to find one of these at a reasonable price. It's rather sort of peculiar looking thing. There are all sorts of different types of angle vices on the market, but this obviously is a sort of quite a cheap import one, which is really good enough for what I'm doing. I'm going to bring you in a bit closer so you can see what I'm doing. I've got the flywheel resting on a parallel in here, and I've put some bits of cardboard on the back and front of the flywheel, hopefully to stop the flywheel from getting marked and hopefully to sort of hold it nicely in position. And I'm going to, if you like, sort of hide the grub screw behind one of the spokes here as well. The plan actually shows putting the grub screw on the outside, but there will be sufficient room for me to lock the grub screw this on the inside. This is going to be the inside of the flywheel when it's mounted on the engine. So let's first make a little flat on here. Obviously I've already set all this up so that I can check everything out beforehand. Bring that right down, and it looks as though I'm going to have sufficient clearance. So here goes. Whoop. That's not good. That's skated a bit then. Bear with me a moment, I'm going to examine this a little bit closer. Yeah, I think the mistake I made there was using the handle to bring the end mill down. I've set it now so that I can use the fine feed to do this. So this will give a much more gentle touch off on the material. I think that's done a better job. Yeah, I've actually done a much better job. I don't think it's made a tiny little mark on the side here, but I think I can very carefully clean that up. That looks all right. So what I can do now is put the spotting drill in. Yeah, that could have been very disastrous actually, that, but there you go. Take put the spotting drill in. I've got to be careful here because make sure that the actually I think I need to extend that out a little bit more because I don't want the edge of the chuck jaws to hit the rim there. Bring that down. How much? I can probably bring it down a fair bit, so hopefully I'm going to be clear. So many things you need to check while you're doing this. Yeah, I think that's okay. Right. That's okay. Remove that. And we put the drill in. Should have plenty of clearance with this one though. Okay, we're through. And we'll start this off with the chuck. Just find my tap wrench. Tighten that a bit more. Just give it a start. And take that right the way down as far as it will go. So and that's it. So we've got our nice 5BA tapped hole for our grub screw. It's a lot of work really, isn't it? Just drill and tap one hole, setting all this up, making sure everything is is nice and square, testing everything out. But that's the fun of it all, really. So that's that really completed. I've just got to make sure I've got no burrs anywhere. It feels all right on the top, but make sure I've got no burr on the inside, which would stop the shaft from going through there. So that's it. So I'm going to have a look at the plans now and see what other parts I can make. There's a couple of quite interesting bits that I can make on the lathe. So perhaps I'll pick out one or both of them and make and sort of add it onto the end of this little video for you. Right, moving on. Well, that's the flywheel completed. It's come out quite nice in the end, all the trials and tribulations of making it, but it's running nice and smoothly, so I'm sort of quite happy with that. Obviously that's going to be locked onto the shaft or spindle there later on. The last bit was drilling and tapping for the little grub screw in here. You can just about see that. And then I ran the reamer through, the 1/4 inch reamer through, just to take any burrs off on the inside. Later on, the grub screw just needs to be shortened slightly because it sticks up a little bit too high there. Something that I did do off camera, because I didn't think it was really worth filming because it was a simple turning job. I used a piece of 3/8 diameter brass, which I drilled and reamed to 1/4 inch, and I've cut it to a length of 3/16 length here, and the idea of that is to give me a spacer for the flywheel, so that the flywheel doesn't touch the bottom part of the casting here. And by having that in place, and then also being able to lock the crank in position here, that will keep that in exactly the right position, so that I can run the eccentric in here and keep it dead centre when I can then lock that in place. Something I also had to go at making with 2 little oilers for the tops here. I didn't film it because I wasn't quite sure whether they would work out or not. They're just a push fit into here, so if I decide to sort of carry on and use them, I can just literally just lock tight those in place, so they'll give a bit more of a reservoir for the shaft or spindle to revolve around and lubricate it nicely. I've noticed that a number of people that have built this engine have done the same. This isn't shown on the plans. They don't suggest that you make oilers at all, only that you drill holes through here and through here as well, so that you can drop some oil in. So if I'm in the mood, I'll make 2 more for here as well. I think that it would make it look quite nice as well, I think, having little oilers on the top. So that could be perhaps the next thing along. So that's it for the moment. So perhaps I'll sort of look to see what other part I can attempt next. This is the next part I'm going to make. This part's called the packing nut. I'll show you in a moment where this actually goes on the engine, but the part is made out of a piece of 1/4 inch hex brass. That's the bit they supply you, which is only just about long enough to machine this part. The part is I think 3/8 of an inch long, which is about half the length of the bit of material that they give you in the kit. So they're not allowing you very much material if you actually make a mistake. So I've got to be careful with this because I don't have any hex bar this size of my own. It needs to be turned down on this front section here to take off all the hex points on the material, and then this is threaded. The plans show quarter UNF, but I do have a quarter UNF die and quarter UNF tap in a kit that I've got of UNC and UNF taps and dies. But the problem is that the tap that I have is a taper tap, and when you actually are going to tap the hole in the part that takes this packing nut, you need a bottoming tap so that the thread will go right the way in. I don't have that, but what I do have is a quarter BSF tap, well, several taps in fact, and a die. So I'm going to be okay cutting the thread on this with the quarter 26 BSF die that I have, and I have got quite a few BSF quarter 26 taps, and among those there are, I think, 1 or 2 bottoming taps, so I'll be okay with that. The small difference really in 26 to 28 is probably not really enough to worry about, and as I'm using primarily sort of UK or British size taps and dies for this anyway, I think that's going to be quite acceptable. But I'm just going to change the camera position so I can actually show you where this part actually goes. Right, when the packing nut's machined out of this piece of small piece of hex bar, it's designed to screw into the boss here on the cylinder cap. The cylinder cap goes basically through this hole. When this is finally machined, the boss on here has got to be machined to go in this hole position here. This I'm obviously going to do that later when I'm getting ready to machine. Probably the last part I do make on this will be the cylinder piston and the top and bottom end caps for it. So that's where the part will screw into. So it has this quarter 26 thread on the outside. There's a bit of hex left at the end of it to enable you to tighten that in, and it will have an 1/8 of an inch hole drilled through the centre to take the piston rod. So basically not actually a very complicated part to make. So what I'll do next, I'll set this up on the lathe so I can face this off, make some measurements on it, and then machine this section down here. So look at the plan, see how long that is. That part, the length of the whole part is 3/8 of an inch, and the part you leave on the end is 3/32. So the part will be machined down, tapped. It will then have a chamfer on the front, which obviously it's going to need anyway to give a lead in for the die. So let's get on with that part next. Well, I've got the hex bar set up in the lathe chuck now, and I've put a little mark here for the length that I need the thread. By taking off the part which will be the hex shoulder, if you like, at the end here, this section here needs to be 9/32 long. So I can bring the tool up to that position, and I can make a sort of a mark now on the part itself. Make sure I've got that nicely in line. Yep, I think that's okay. Right, so let's proceed. We're nearly down to size. What I'll do is I'll bring you back when I've got this down to the correct size. Well, I've got that down to size, and I've just put a little chamfer on the front of it to help the die. So I'll get that out the way, and next I'll drill the 1/8 inch hole through. Just centre drill that first. Okay, I've actually marked the drill for depth just a fraction over the 3/8 of an inch length that part's going to be. But quite frankly, what's left of this, if I mess this up, there's not enough material to do it again. So if I mess this up, I just have to buy a piece of hex bar that size. Anyway, let's bring that up to position. Okay, so let's drill that out. That gives us our depth. So the next job's going to be threading the outside here with the 1/4 BSF thread. I'll just set all that up next. Right, let's have a go with threading this part. Okay, so what I'm going to do is I've turned the die round so that I can bring the thread up to the little shoulder here as far as I can. Realised I've not made life very easy for myself here, because the other day I was messing around with the lathe and I put the rear tool post on, so I've got hardly any room to get in here now, but I just have to get around that as best as I possibly can. Anyway, I'll bring you back once I've got that part sorted out. Right, so all I really need to do now is to part this off to length, 3/8 of an inch. I've just cleaned things up a little bit as well, just re-chamfered at the end here, and try to put just a tiny little chamfer on the hex part here. I'm not using the rear tool post to do this, because you can see even with this parting off tool, which is the thinnest one I've got, this is 60 thousandths of an inch wide, I'm perilously close to the chuck. I don't really want to move the material out any further, really, because there's not an awful lot gripping in the chuck anyway, as you can see. So but this should be okay. I'll put a little rod in here to hopefully catch the part, because now I've machined this, I don't want to lose it, because I won't be able to make another one. Right, let's have a go. I've slowed the motor right down as well. There's something wrong here. It's decided to move itself nearer to the chuck for some reason. Don't know quite what happened there, but let's go in again. Maybe it's that the hex bit that's pushed it over slightly. Let's get that on again into place. And also, if I can find the chuck key, I'll lock that in even firmer. There we are. Just make sure that it's not loose at all. I think we're okay. Okay, let's have another try. Right, gonna have to investigate what's going on here. Bear with me. Right, we've got that sorted out. I've actually brought the material out just very slightly from the chuck. The parting off tool was just a fraction too high, so it was rubbing. But I think I've got it okay now. So let's have another go. It does seem to be cutting okay now. That's it. So we can get this all out of the way. Well, I've turned it round in the chuck. I've actually gripped it on the threads, not the hex, because there's not really enough room on the hex to do this. So I've just cleaned up the face here. So I just really only need to put another little chamfer on the front side of this as well. Yeah, I think that's all it needs. So that part is now finished. can remove that. So that's that tiny little part done with the 1/8 inch hole through, so the little piston shaft will run through that. That literally is all that was left over from the hex bar, not even 3/8 long. So if I'd have made a total mess of this, which I almost did, I wouldn't have had any material to make another one of these, so I've got to make sure I don't lose it either. So that finishes that little part now. So I think we'll leave it at that for this little episode. I've got one other small part to make, which is the piston valve linkage. That's also made out of hex brass, but an even smaller size. I think it's a 3/16 piece of material, so I'll probably do that next, because I think that after that I'm now committed to start work on the cylinder covers and piston. I think that's what comes up after that, so we'll see how we get on. So anyway, well, thank you very much for joining me in the workshop again. Much obliged to you for working along with me. Bear with me just 1 second also, just to show you that is the part that runs through it. It's just that way round. That's the piston rod. So that end attaches to the piston itself and is locked on with a little nut, and this end attaches to the cross head, so that runs through there quite nicely. And then obviously there'll be some sort of packing in here, which I think is Teflon material. So I imagine that not all of that thread is screwed into position. I guess there'll be a little bit on the outside as well. But there we are. Again, thanks for joining me. Thank you also for all the subscribers to the channel. If you've not subscribed already, please do. And if you've got any comments, do drop me any comments, any sort of questions on the build, or if you think I could be doing anything better than I am doing, do let me know. I'm pleased to receive any help at all. So that's it from me. Bye for now.